Lego pieces and you melt them, and then you stick in the molted plastic in this machine, and the little mold that you just etched out with your CNC machine, and you go, and out comes a Lego sniper rifle. And he made 1 or 2 and 3, and he showed them to people, and it was pretty cool. And so then what he did is he said, you know what? This might be more than just a toy for my children. This could be a little business. And so he then uploaded these same files to a local machine shop, and they made the molds not in aluminum, but in stainless steel. And then they uploaded that then they sent that to a local injection molding plant. And now he makes tens of thousands of these every year. And today, Brick Arms is a thriving business. He quit his job as a software developer, and now he says he makes more money on a bad day selling Lego weapons than he ever made on a good day as a software developer. And there are like 30 other companies in the Lego ecosystem, Brickforge and others, who are making sort of Lego accessories that Lego won't make. Now, this is a really interesting example. These are entrepreneurs. These are people who went from hobbyists and followed their passion into business. And they're now in the Lego industry, but they don't have factories. They don't have, capital. They're not Lego. They're not endorsed by Lego. What they have is access to the tools of production and distribution. They design products using those same tools I just told you about, and they distribute on the internet, often using drop shipping. So you say, well, how does Lego feel about this? And the answer is they feel great about it. And here's why. The biggest problem for Lego is that most of their customers are boys, and boys get tired of Lego at about 9. They want to keep their fans longer, but they don't want to make weapons because that's not their corporate policy. They also only make products in units of millions. It's like they'll make a product if it will sell in 1 million, but they will not make a product if it will sell in 10,000. But there are lots of markets for products of 10,000. So they don't want to be in that business, and yet as those boys get older, they're going to tend to gravitate towards the more niche products that sell in the 10,000s. So what they need is a second order, a second tier of companies around Lego that are focusing on the niche markets. And that's what you now have with all these adult fans of Lego, or these Lego entrepreneurs. They're targeting the long tail of Lego demand. And that long tail of Lego demand not only satisfies the marketplace, but keeps these boys in the Lego world longer, from 9 to 10 to 12 to 13, all the way into adults. And so it solves everybody's problems. It's a fantastic kind of big little head-tail collaboration that's enabled by the fact that everybody has access to the tools of production and distribution. So this is my story. I too was into Lego with my children. We were into Lego robotics and Lego Mindstorms, but the problem was that we made the kits, but then we couldn't figure out what else to do. It seemed like everybody had already done all the cool stuff, and then somebody gave us a model airplane, and we crashed it. And we're like bad at Lego and bad at model airplanes, and I felt like a bad father. And then it occurred to me, well, what if we had the Lego robotics fly the airplane? That would be cool. So we did that, and with the kids. And then I thought, well, what if, maybe Lego's not the right way. What if we designed our own autopilot? And basically it became clear to me that we were at a moment where the sensors that are in your phone, the GPS, the gyroscopes, the accelerometers, the wireless, that the sensors in your phone are the components of a autopilot. You can fly an airplane with a phone. And so started doing this, and then realized that you actually wanted to design custom electronics, and we eventually started a community. This community was based on amateurs and volunteers, but we were going to open source autopilots and give planes brains. We were going to develop the computers that would allow planes to fly themselves with waypoints and missions and completely hands-off, take off by itself, land by itself, take pictures, all this kind of stuff. Do the kind of stuff that the aerospace industry does today, but we were going to do it at a very, very cheap, very fast, and open source, just like those cars. So we started this, and again, I am not an engineer. I have no business doing this. This is sophisticated electronics, the kind of stuff that Boeing and Lockheed Martin do. So what made me think that I could make an autopilot? And the answer is that the tools of production, the tools of prototyping we're now available to everybody. So there's these free software called Eagle from CADsoft, and you can design a circuit like this. You can lay out a board like that. And then you can just upload this, these files to any kind of firms, just like Alibaba. And these firms will then create the printed circuit boards, put the chips on it, and send it back to you. So you can get into the manufacturing business of sophisticated electronics. The kind of stuff that Sony makes, you can make. And it doesn't take that many skills. There's communities out there that'll help you. So this is now what we do. We make autopilots, computers to fly airplanes. This is pretty amazing. And again, total amateurs. It's all open source. Now, I told you before about how the open source car had advantages over closed source because they were unregulated. They didn't have to go through crash testing and airbags and all that. Well, we have the same thing. If you're making autopilots for commercial use, they're export controlled. You can't ship them outside the United States without going through this large, they're regulated as weapons. You can't fly in the air without getting a special certificate from the FAA. And the barriers to entry are really, really high. If, however, you give them away, if you do it as an open source project, it's exempted by public domain. If you do it as a community, your R&D costs are zero. If you have the ultimate consumer put together the parts themselves and participate in the final assembly of the product, you're again exempted from a lot of the kind of consumer protection stuff. It's not considered a consumer electronics device. It's considered a kit. It's regulated under a different category. And so we're able to get out faster, cheaper, better, and innovate much more quickly than the biggest aerospace companies in the world. Not because we have more money or more resources or smarter people, because we have a better model. And the model is the web model. We've applied the web model to manufacturing, and by doing so, and by doing it in open source, under Creative Commons and the GPL, we have found a way to route right through the regulatory and economic barriers that have made it so hard to be an entrepreneur in aerospace to date. So I thought that was pretty cool. But remember that my grandfather did automatic sprinklers. I thought, well, autopilots are a little bit geeky. I should find something that's a little easier for people to understand. This model can apply to anything. So I said, if my grandfather were alive today, how would he be inventing the automatic sprinkler system today? And the answer is he'd be doing it the same way as an open source community. So I have another partner there, a guy named Roy Wang, and this is an open source, our first open source sprinkler. And it's based on the Arduino open source hardware platform, just like our autopilots. And it recognizes that almost anything can be transformed if you open source it. Well, just think of sprinklers, for example. Why do you want an open source sprinkler system? Well, if you have a sprinkler system at home today, can you access it on your phone? Probably not. If it's going to rain tomorrow, will your system know not to sprinkle today? Probably not. Do you have sensors that'll tell you what the, how dry your soil is right now? And can you see those sensors on your phone right now? Probably not. Is it connected to the web? Probably not. And by the way, can you add your own sensors? And can you invent new ways to do it? And can you build your own business around this? Probably not. Again, almost anything, if you open it up and expose it to a community, can create new use models. You can find new ways of doing things faster, cheaper, and better by opening the technology to people who think different. These are not ideas that the big sprinkler companies would have thought of. These are ideas that users will have thought of. Now, I'm embarrassed to say that the first users of these devices turn out to be pot growers. And it probably makes sense that the people who need the most granular control over their watering are people who are growing marijuana. But over time, we hope that this will expand to more traditional uses. But that's the cool thing. I mean, we don't know what the uses are. We have to we put the technology out there, and then people figure out what the uses are for. And this exactly is the same as the web. When people invented the internet, when they invented the web, they didn't know what it was for. They invented TCP/IP, they invented HTTP, but we, the regular people, figured out how to fill it with content and communities and function. And this is the notion of open source. If you open a technology, people will find uses for it. So I wanted to end with this is our business model, by the way. We just we give away the bits and we sell the atoms. And we sell the atoms at 2.6 times the cost. It is the most obvious business model in the world. We make a profit. The business model is baked in. The moment you're dealing with atoms, it's regular business. You make money because you're selling a good. 100% of the companies in this space are for profit because that's the right way to do it. It's a regular business, and if you're for profit, you can grow. So the point is simply this, that for the first time in history, making is manufacturing. Because the files start as digital files on computers, you can print local, you can print global. You can make 1, you can make 1 million. It's the same technology from end to end, that the global supply chains are now matched to the individual in the same way that the internet was matched to the individual. It doesn't favor the big over the small. It is agnostic as to scale. This is the grounds for an industrial revolution. So I wanted to show you some of the sites that could be used. If you don't have your own 3D printer, you can go to Shapeways and you can print in any material you want: plastic, glass, stainless steel, bronze, gold, silver. You can do jewelry, you can do machine parts, anything you want. You can go to a site called Ponoko, and they will help for things like laser cutting and to put the assembly, and can get you into business very, very quickly. And in a sense, what we're seeing here is kind of a new economic model. And I just want to sort of end on this note. The guy on the left represents the 20th century industrial model. His name's Ronald Coase, University of Chicago economist. And he came up with a theory of the firm. In the 1930s, people were asking, why do companies exist? Countries are based on democratic principles, voting. Companies are based on dictatorships, command and control. Why do companies exist? And Ronald Coase came up with the idea of transaction costs. Companies exist to minimize transaction costs, which is to say that the reason we have a company and we hire employees and give them jobs is to make it easier to get things done. So the person to the left of you does accounts receivable, and the person to the right of you does accounts payable, and everyone's got a role, and you know where to